Hello, class 10th physics, magnetic effect of current. Today's topic, electric motor. So, so electric motor is a device used to convert electromagnetic energy into mechanical energy. Next is its principle. On which principle it work? Whenever a current carrying coil is placed in a magnetic field, it experiences rotational effect of force. As we know that when a current carrying conductor is placed in a magnetic field, then it experiences a force. And instead, a conductor, if we place a current carrying coil, then it experiences a rotational effect of force, turning effect of force. So later on we will see this, how does it work. But most of the time in class 10th, this is not uh, mm, generally written as the principle of electric motor. Rather than we write Fleming left hand rule as principle of electric motor. So it is based upon Fleming's left hand rule as far as the direction of motion of coil of motor is concerned. So according to according to Fleming left hand rule, let's see this clip. It looks quite lengthier, but you can develop it in your own words also. If we stretch thumb, index finger, and middle finger of left hand, this is important because we can do it in using our right hand also. So that is important. Of left hand, mutually perpendicular to each other. They must be perpendicular to each other. And if index finger shows the direction of magnetic field, middle finger shows the direction of current or motion of positive charge, then thumb shows the direction of magnetic force experienced by the conductor or that positive charge. So sometimes casually students say that, okay, according to this law, thumb shows. Before I tell you the construction of, yeah, or the designing tip of electric motor. So let's discuss that how does an electric motor work in a practical manner, and then I will cover its construction part and its working part. So we know that if there is a magnetic field, there will be a magnetic field coming from North Pole and terminating at South Pole. And if we place a current carrying wire in it, now see, according to left hand rule, it shows direction of magnetic field. Middle finger shows direction of current, which is this time downward. Actually, this is our structure: magnetic field, current, and magnetic force acting on current. So now you can see magnetic field along this way, current going downward. So generally we show it like this, but this time it is going downward. So now I will turn my finger along the direction of current. So thumb is pointing outward of the plane of the paper. So this is the direction of force. Oh, sorry, dot. Ignore this. Coming out is also dot. Accept it as a dot. Means force is coming out. Now let us suppose in another situation, again there's magnetic field and there is a current carrying conductor which is carrying current in upward direction. Then magnetic field along this way, current going upward. So force is going inward. Now let us suppose we have one of the wire going in upward direction, other wire going downward direction. So this time I'm not drawing too many lines. Okay, so we know for this wire magnetic force will be outward, and for this wire magnetic force will be inward. And let us suppose we join this, and it is nothing but a coil. don't get surprised. Coil doesn't mean it must be circular. It can be rectangular or square shape coil. It must have the structure of this turn. It must turn. Okay, so this is a coil. And now see, if this is a coil, this portion, this wire is experiencing force outward, and this one experiencing force downward. It will rotate like this. And this is what I have written over there. Whenever a current carrying coil is placed in a magnetic field, it experiences rotational effect of force. This is rotational effect of force. It is going this way. Now, just imagine if we are supplying some current in this coil like this circuit. Now, if it would turn, then these wires will twisted together. So we require a trick by which it should not be twisted. Then what is the idea? So see this demo. Um, Actually, I have also seen it from somewhere else, so not entire credit not goes to me. But see, so in the demo, I used a circular coil like this, and somehow I attached it. There are magnets, and I made a hook like structure here and here, and then supplied current. I use circular one. I could use rectangular one also, but to explain you that turning effect, it is much easier for me to use that rectangular shape. But for that experiment, I used circular coil. So here, if it rotates, it is sliding over these hooks, and circuit is not getting entangled with itself, as we can expect from here. If it is going, if it is turning, then that wire will get twisted, and because of that we can't use it for a longer time. So, but this is not a practical design. We can't use it commercially. For demo purpose it is okay. So commercially, what is the idea for this is we use this rectangular coil, and we connect a semicircular metallic connector from both the ends, and then we take graphite connectors, and why graphite connectors? Because when these metallic semicircular connectors will rotate, they will slide over these graphite connectors, and this is how it is going to work. So these poles are called field magnets. This is called armature coil. Armature coil together is a name of insulated copper coil wound over iron core. Armature coil means not just a coil, but a system in which there is insulated copper wire wound over laminated iron core. I will explain about it later on. These two semicircular conductors, these are called split rings. And this is most of the time it is called carbon brush. Actually, it is graphite connector. So working is when circuit it is not writing well, is switched on, then current flows along DABC. DA experience force, and we know in which direction, downward. You can see current is going up, magnetic field this way, force going downward, experience force in downward direction. And BC in upward direction. So the coil rotates, and after half rotation, now what happens? So after half rotation, like this BC part comes on left side and AD part goes on other side, and the way current is going this way. So actually these split rings are also called commutator. So now you can see they commute the direction of current. So okay, I'm writing this carbon brush as B1 and this one as B2, and this slip ring as S1 and this as S2. Now after half rotation, B1 will remain at its position, B2 will remain at its position. They will not rotate. See, I told you about that, if this function is not there, then wire will get entangled. But now what is happening? These graphite blocks or carbon brushes are not moving, but these slip rings are sliding over them. So earlier this one S1, now after rotation this S1 goes this side, and that S2 comes this side. And now once again, due to current, it is downward and this is upward, and this will go on and on and on. Okay, I'll write this thing here. AD and BC interchange their positions, and according to diagram, BC experience force in downward direction, while AD in upward direction. Finally, the coil rotates about an axis passing through the plane from the middle and parallel to AB, oh sorry, AD and BC. So ultimately, this rotation goes on and on and on, and by this we can convert this electromagnetic energy into mechanical energy. Now, what are the uses of electric motor? Write down me in the comments. But before that, I will tell you a brief definition of armature. Okay, armature coil. It is an insulated copper coil, copper preferably. It can be aluminium also. Copper coil wound over a laminated iron core. Now, what is the meaning of laminated? Which is in the form of thin sheets stick together. Why we use that laminated core? Again, it is the concept of higher physics. But if you still want to know about it, write down me in the comments. I have made a separate video. One thing generally asked, other than this armature coil, about split ring. Most of the time its application or its significance is asked in the exam, so you can explain it that if it is not there, then wire will get entangled, and you can give a good description about that. But in order to save time and give appropriate answer, you can write it commutes the current in the coil. Oh god, in the coil. That's all. And uh, other than that, you can, after writing this, you can draw the diagram that this is how it is commuting. And by drawing diagram, you will able to save lots and lots of time. So that's all for today. Bye bye.